Yeah.
I'm hoping it will pop up on YouTube.
It's rolling there.
I'm keeping an eye on YouTube.
Yeah, that's scrolling. Do you want to let everybody in on Zoom then?
Are we?
That was running, Brendan. I'm not sure what you've just done now.
My apologies. I needed to mute the live feed on my laptop for YouTube because it was coming through as well as Zoom.
So we're rolling now.
Do you want me to let everybody in?
What will happen then? I can just click my talk
And take over.
Great.
Do you want me to let everybody in now?
Well,
Brendan? Yes?
If you would.
Okay.
Right, so we are going live on audio as well, so at least we will be if I press the right button.
Oh, there we go.
Okay.
Where's the volume?
Right. So just for those of you on, I've muted everyone who's joining at the moment, just so we don't get too much background noise. If you need to unmute to ask a question before we start the formal presentations, just do so. And just a word to Rob and Brendan, you're both on mute as well. Brendan, I've just sent you a message. Could you just have a quick read of it?
Right, it's on. It's on. Yeah.
Hello, Brendan. Hello.
I remember. Switch that stuff off.
We're going back in time to watch some of our favourite beaches you may have seen. I don't know. What happened?
See, it's unmuted.
How is that even possible?
Just a quick word, we'll be starting in a couple of minutes. We're still getting people joining, so we'll just give it another couple of minutes.
Good evening.
Evening. I'm just going to put everybody on mute. Rob, we're at 100 now, which is our capacity, so you might as well start.
Hi, Steve. Steve?
Yes?
You can hear me, good. Okay, brilliant.
Yeah, so I was just saying we're at 100. Well, we're actually gone down to 99, but we were at 100, so you might as well start since it's
Okay, are they all on Zoom or?
we've got 100 on Zoom. I don't know how many we've got on YouTube.
Okay, right, no problem. So we're just still running the rolling presentation at the moment, aren't we?
Yeah, and you're live with everybody. So yeah.
Okay, right, okay, let's go. Good evening, everyone, and welcome to Mansfield and Sutton Astronomical Society. It's good to see so many society members on board tonight, and a very warm welcome to all non-society members. Our home is Sherwood Observatory in Sutton in Ashfield, and we were founded 50 years ago by a small group of far-sighted astronomy enthusiasts. Over the intervening years, our membership has grown and we currently hover around the 100+ mark. We have a very active outreach programme that is supported by our members, and this encompasses all uniformed associations such as Brownies, Guides, Scouts, and many others like Unit 3As and schools. Visitor numbers to our observatory are around the 3,000 mark.
Never gone more than a year or two without finding some new area.
For any non-members with us tonight.
Sorry, could I just ask that everyone but Rob puts on mute, please, because we're getting background noise. Thank you. Sorry, Rob.
Okay, thanks, Steve. For any non-members with us tonight, please feel free to peruse our website, as we have many useful, interesting astronomy links, including the link to download a membership form. Ordinarily, an event like this would be held at our society, which is Sherwood Observatory in Sutton in Ashfield, home to one of the largest public telescopes in the country. Our members enjoy a social and all things relating to astronomy bond to try and maximise enjoyment in our passion. As a member, society equipment can be used and borrowed and technical advice sought, also enjoying a monthly guest speaker of high calibre. So if you're all sitting comfortably, we'll get on with our part of National Astronomy Week with a trip to one of our neighbours, an object that has captivated humans for millennia. So let's get started. I might add at this point, if you have any questions, please put them in the chat, or could you wait until the very end, please? And again, if you could mute your microphone, that would be much appreciated. Let's try. Yes. Oops. Okay. Here is a simplified version of our solar system. All the planets up to and including...
Rob,
hello.
you're not sharing your screen at the moment.
Oh. Okay. It says your screen sharing. Is that going? Yes.
Yeah, that's okay. I've got that.
Are we sharing?
Yes.
Brilliant. Thank you. Wow, technology. Don't you just love it? There we go. Seamlessly moving on. All the planets up to and including Saturn are naked eye objects, meaning you don't need an optical aid to see them. And these have been known to humans for thousands of years. Mars came into being about 4.5 billion years ago, when part of the solar nebula collapsed to start the formation process that resulted in the second smallest planet in our solar system. Mars, the fourth planet from the sun. For the ancient Romans, it was their god of war, but for many today, it holds much more significant belief. Could Mars have harbored life, and could humans ever live on Mars? So began the human fascination with this ancient wanderer. Since the advent of telescopes, Mars has become a magnet for humans, leading to speculation about life elsewhere in our solar system and beyond. Dark spots and blurry shapes fueled thoughts of seas, canals, and with the discovery of ice caps, conjuring images of fragile life clinging on. In 1894, Mars was close to Earth, so astronomers took the opportunity to have a look at Mars to see if there were any signs of intelligent life. Well, back in the day, they didn't have good cameras to take proper pictures, so they had to draw what they believed they saw. And boy, did they draw. One astronomer, Percival Lowell, thought he saw canals and that they must have been built by intelligent beings. These discoveries only fueled our desire to visit the red planet and meet its inhabitants. As time moved on, the space age ushered in a new era of exploration. Humans had a new means of investigating our neighbours. After an 8-month voyage, Mariner 4 became the first spacecraft to take close-up images of another planet during its flyby. 21 black and white pictures from Mariner 4 were beamed back to Earth. No more blurry images through ground-based telescopes. Instead, blurry photographs. The image shows a lunar-type landscape and was transmitted on July the 5th, 1965. This brief glimpse said a lot about Mars. The craters were estimated to be billions of years old. This told scientists that the atmosphere of Mars must be very thin to preserve them for so long. Mariner 4's brief glimpse revealed no rivers, mountains, or valleys. These would come later. This mission made NASA realize it wasn't going to be easy discovering life. The view was taken that Mariner 4 had only spent 30 minutes at work on the red planet and had looked at just a small portion of Mars. Life, if there was or is any, it could be in the microenvironment scale, and given the conditions we see today, to survive, it would have to be as tough as Fred Dibner. There's an area around a star referred to as a Goldilocks zone, a zone where liquid, water can exist as solid, as in ice, as liquid, water, and as a gas, vapor. Mars is in the Goldilocks zone. Life is found in extreme conditions, hot and cold. Life adapts. In our solar system, we have 4 terrestrial planets. Venus, Earth, and Mars in the early solar system were probably very comparable to each other. But now we have a planet doing a good impression of a self-cleaning oven and another doing a good turn as a vacuum freezer. Can we piece together the past evidence on how Venus and Mars ended up as they are now? Mars, with its 25-degree axial tilt, allowing for seasons similar to Earth's, a rotation period of 24 hours, 37 minutes, just 42 minutes longer than Earth's. We would feel at home with this time period, and a year almost twice as long. But just how did Mars evolve into what we see today? Are these 2 planets that bookend Earth trying to tell us something? I might add that this is the old Goldilocks scenario, and now we have to consider a Goldilocks scenario of moons around planets, such as the Galilean moons around Jupiter. So various space agencies from around the world put Mars on their radar. 50% of all Martian exploration missions fail for one reason or another. If the term failure to reach orbit or an unscheduled disassembly is used, it usually means that the rocket blew up. So far, the successful landings have been the 2 Viking probes, Vikings 1 and 2, the Mars Pathfinder, Spirit and Opportunity, both rovers, the Polar Lander Phoenix, and the latest is Curiosity, currently in Gale Crater, another rover. All this activity has built up our understanding of Mars. Billions of years ago, when Mars was a very young planet, its internal changes of the planet created huge, large-scale features that we can see today on its surface. Areas such as the Tharsis Bulge were raised, and other areas were stretched and pulled apart, creating rift valleys, later to be modified by wind, water, and landslides. One such feature is Vallis Marineris, running west to east, just below the equator. It is by far the largest feature formed by tectonic activity on Mars. The deepest point is about 7,000 meters deep. That's 3 times as deep as the Grand Canyon in the United States. Its width exceeds about 500 kilometers, and end to end is about 4,000 kilometers long. The western end, that bit up here, is marked by Noctis Labyrinthus, which is Latin for labyrinth of the night. I think you've just got to love these names. This is a complex fracture system of valleys caused by the intense volcanic activity in the Tharsis Bulge. The eastern end of Vallis Marineris is marked by smaller canyons, depressions, which lead out to outflow canyons. And these outflow canyons lead to the northern lowland areas called Chrysae Planitia. Mars has 2 moons. These are believed to be captured asteroids. Phobos, it's the biggest of the 2. It's about 26 kilometers in length. It takes about 7 hours to do one orbit, and at a distance of 9,000 kilometers. The other moon is Deimos. It's a little bit smaller, about 15 kilometers, and that's takes around 30 hours to do one orbit, and that's at a distance of around 23,500 kilometers. Phobos is getting ever closer to Mars, and one day it will either break up through tidal forces or collide with a planet, creating another crater. And Mars is about half the size of planet Earth. Now, I struggle really to get that in my head, so it's roughly a little bit bigger than the width of Africa. And the whole of Mars is equivalent to all the land surface on planet Earth. Like its terrestrial neighbours, Mars is dense and has a rocky composition. At the centre is a core, probably of iron with nickel and sulphur. This may have solidified now because smaller objects tend to cool down quicker and radiate the heat away. But in its earlier life, it may have produced a magnetic field to protect the planet from the harmful solar radiation and cosmic rays. This would have helped Mars to retain its atmosphere, thus enabling life to possibly evolve on the planet. Around the core is a rocky mantle of silicate minerals and a crust rich in iron. These iron minerals react with the trace amounts of oxygen in the atmosphere and rust, giving the planet its signature red colour. Today, Mars is a desert world, drier than any on planet Earth, with average temperatures of minus 63 degrees Celsius, with a low at the poles of minus 142 degrees Celsius in winter, to a high of around 20 degrees Celsius at midday at the equator. Quite cold, but not off-putting to future human excursions to Mars. It's a little like living in Antarctica. And we've got the top left image is Murray Buttes. The one on the right is Mount Sharp itself, and the bottom one is Mount Sharp, and the one on the right is Maria's Pass. All these images were taken from the Curiosity rover, which is currently exploring Gale Crater. Planetary scientists have looked at numerous areas on Mars and found that they compare favourably with what we see here on Earth. For example, these are either river channels or glacial runoff channels, either way indicating a surface that has been altered by liquid water flowing constantly over a considerable time scale or episodes of large volumes of water flowing. Volcanoes would have pumped out huge amounts of gases into the Martian atmosphere, helping to keep the planet much warmer than what we see today. This is the Tharsis region. It's about 4,000 kilometres across and up to 10 kilometres high. It's approximately the size of Australia. It's home to 3 giant shield volcanoes. We've got at the bottom, we've got Arceus Mons. In the middle, we've got Pavonis. And at the top, we've got Ascraeus Mons. In addition, to these main volcanoes in this area, there are several smaller volcanoes located in and around this area. It begs the question, was this an ancient hotspot on Mars in its early life? Had there been plate tectonics? This looks like a little bit like the Hawaiian Islands in the Pacific, where they've got a localized hotspot and the Pacific Ocean plate moves on it and it burns its way through, creating an island, shuts down, and the plate moves on, erupts again, creating another island. To me, it looks a little bit like that. All these are several hundred kilometres in diameter and range in height from 14 to 18 kilometres high. These have been built up by countless episodes of lava and ash deposits. The Tharsis region is so massive that it has placed immense strain on the planet's lithosphere, hence Noctis Labyrinthis at the end of the eastern end of Vallis Marineris, literally pulling the planet apart. Olympus Mons, the tallest known volcano in the solar system. It is around 25 kilometres high, and an average width of around 550 kilometres. Olympus Mons is rimmed in places by cliffs approximately 6 kilometres in height. Did an ancient sea lap up against these cliffs billions of years ago? The caldera is 80 kilometres in diameter, and if you stood on one end of the caldera, the other end would be below the horizon. Around the time of the dinosaurs were becoming extinct on Earth, the volcanoes on Mars were shutting down. The evidence gathered so far by all the various orbiters and landers seems to indicate that Mars of billions of years ago may have been very different. Perhaps something we could relate to today. To date, though, there is no reliable evidence of liquid water on Mars. Today, most of the water on Mars is held as ice in the northern and southern polar ice caps, just below the surface in the northern plains. When the Martian polar caps were first viewed through telescopes, most scientists believe that they were made of water ice, like the polar caps here on Earth. Like Earth, Mars has a north and south pole, but while Earth's polar caps consist solely of water ice, Mars polar caps are a combination of water ice and carbon dioxide ice. As the Martian seasons change, the carbon dioxide sublimates, vaporizes from a solid to a gas during the summer, revealing the surface, and freezes again in the winter. As autumn approaches in each respective hemisphere, clouds begin to form over the polar regions and the ice cap begins to grow. In the spring, the polar caps recede again. NASA is searching for life in the past by following the water trail, which is a logical way to proceed, as where we find water, even acidic water, life seems to have a way of surviving and thriving. This is NASA's latest attempt in this ever-evolving journey. This latest rover is an evolution of all previous rovers. It's bigger, so able to carry more instruments. Bigger wheels allow it to traverse more difficult but interesting terrain. Nuclear power, so no problem with dust on the solar panels. It's around 3 meters long, 2.7 meters wide, and 2.2 meters in total height. And the weight is just over 1,000 kilograms. It's about 126 kilos heavier than the rover that is currently in Gale Crater, Curiosity. The main aim is to look for signs of ancient life. The landing site is Jezero Crater, a 45-mile wide crater just north of the Martian equator. Perseverance will spend 1 Martian year, equivalent to 2 Earth years, exploring the landing site region. This landing is expected to take place on February the 18th, 2021. And the reason to go into this location? Well, scientists think Jezero Crater was a site of an ancient lake. So what does Perseverance do during the surface operations? Well, it has a list of objectives. Objective A is to find rocks that formed in or were altered by environments that could have supported microbial life in Mars' ancient past. Objective B, find rocks capable of preserving chemical traces of ancient life and the biosignatures, if any, existed. And Objective C, drill core samples from about 30 promising rocks and soil or regolith targets and cache them on this Martian surface. These hopefully will be returned to Earth on later missions. Perseverance rover is also a technology test bed. On board is what's called a MOXIE instrument, and that's located inside the body of the rover. This will test technology that converts carbon dioxide, the Martian air, into oxygen using local resources found on the planet. This is going to be really important to future human missions to Mars. Stowed beneath the rover, just there. Oops, come on, I can't get it. Oops, sorry, just there, stowed underneath the rover, is Ingenuity, a Mars helicopter. It's an autonomous rotorcraft. In the months after landing, the helicopter was placed on the surface to test for the very first time powered flight in the thin Martian air. Its performance during these experimental test flights will help inform decisions relating to considering small helicopters for future Mars missions, where they could perform in a support role as robotic scouts, surveying the terrain from above, or as full standalone science craft, carrying the instruments payload. Taken to the air would give scientists a new perspective on a region's geology, even allowing them to peer into areas that are too steep or slippery, dangerous to send a rover. In the distant future, they might even help astronauts explore Mars. And the dimensions of this helicopter is about 0.5 meter in height and 1.2 meters from wingtip to wingtip. And the weight is 1.8 kilos, and it's solar powered, and it's able to recharge itself. It has wireless communications with the rover, and it has counter-rotating blades. And these spin at just over 2,400 RPM, much faster than helicopters here on Earth. It's equipped with computers, navigation sensors, and 2 cameras, one colour, one black and white. The helicopter may fly for up to 90 seconds to a distance of almost 300 meters at a time, and about 3 to 5 meters above the ground. Just consider this for a moment. December the 17th, 1903, at a place called Kitty Hawk, North Carolina, the first heavier-than-air powered flight. That first flight lasted 12 seconds and flew 120 feet. The flight of the Wright brothers' first powered aeroplane, I should say. The success of these two technologies, the Moxie and the rotorcraft, aren't related to the success of Perseverance rover. They're just technology test beds. But to get to that point, Perseverance has to negotiate 7 minutes of terror. Mars has a thin atmosphere, but it's got to burn its way through first, and that's 7 minutes. The descent stage will use a new terrain relative navigation. This avoids tricky terrain. And how it works, it uses images from the Mars orbiters. The mission team creates a map of the landing site, and the rover stores this map in its new computer brain, designed specifically to support terrain relative navigation. Descending on its parachute, the rover takes pictures of the fast approaching surface, and this is to figure out where it's headed. The rover quickly compares the landmarks it sees in the images to its onboard map. Armed with this knowledge, where it's headed, the rover searches another onboard map of safe landing zones to find the safest place it can reach. The rover can avoid dangerous ground of up to about 335 meters in diameter. It's about the size of 3 football fields end to end. It can do this by diverting itself towards safer landing ground. This new technology will enable Perseverance to land much closer to its intended target area, possibly shaving as much as a year off surface travel time. Sometimes you don't have to go to Mars to explore for life. Sometimes Mars comes to us here on Earth. This is a picture of meteorite ALH 84001, found in 1984 by geologists in the Allen Hills region of Antarctica. Formed about 4 billion years ago on Mars and landed on Earth about 13,000 years ago. And studied under an electron microscope. This is a very powerful microscope. And they found what looked like segmented fossilized life structures. However, these are much smaller than the smallest ones found here on Earth. So the current thinking is that they are too small to represent life, and they may well be unusual mineral deposits. To date, no conclusive evidence of life on Mars has been found. But even if ALH 84001 did not conclusively prove the existence of life on Mars, the research did benefit science and resulted in NASA's Mars exploration program being reinstated. The Mars exploration rovers, the Mars reconnaissance orbiter, Phoenix lander, Mars Express mission with its Beagle 2 Mars lander, all can be traced to the research on this particular meteorite. The excitement of the possibility of life, past or present on Mars, is too important for humans to ignore. Could pieces of Mars blasted off the surface have possibly seeded Earth with life millions of years ago? On that bombshell, my fellow Martians, I hope you enjoyed this part of Mansfield and Sutton's Society webcast. I'm now going to hand you over to my fellow member, as I believe the doctor will see you now. So please enjoy Dr. Steve Wallace. Thank you.
Thanks, Rob. Very good. I said during the chat, if anyone wants to ask any questions, just put them on the chat. Rob, one thing that worked well, since we're kind of experimenting with this, is when you were doing your talk, I was keeping the eye on the chat and just picking things up that people were saying on the chat. So if you could do the same for me, that would be great. Okay, so what I'm going to do is share a presentation now and go through a presentation about the observatory itself. What the history of it is, Rob touched on that a little bit, and what we do at the moment, and what our plans are for the future. So if you just give me a moment, I will share my screen and start the presentation. Right, okay, if somebody could just confirm that they can see that, that would be great.
Yep, got it, Steve.
Yeah,
Okay.
I'll go it as well.
Brilliant, thank you. All I've got to do is make it work, which it doesn't seem to want to do at the moment. Right, great, there you are, thank you. So what I'm going to be talking about, we're doing a lot of work at the moment to expand our facilities, because in a normal year, what we'd be doing is doing opening evenings like this totally live. So you'd be coming to the observatory rather than listening to us on Zoom. You know, we can get upwards of 200 people at the observatory, and with something like a 35 space car park, that is somewhat challenging. So we're planning on expanding because there seems to be so much demand for this in the area. So what I'm going to do is, first of all, mention some of our supporters that have been helping us with that. I'll go through a history of the observatory, the work that we do in outreach, and then our plans to build a planetarium next to our observatory. So first of all these companies on the left and universities and the East Midlands Chamber of Commerce who have been helping us free of charge over the last couple of years in various ways. I haven't got time to go through what all of them are doing, but I will mention a couple of them in a moment. The ones on the right, the Heritage Fund, Ashfield Council and the Architectural Heritage Fund, have actually been giving us some donations of money to allow us to do feasibility studies and things like that to further develop our plans. But this evening, I just wanted to mention Block Digital first, and also the University of Nottingham. The reason for that is all of the animated images, all of the images you'll see in this presentation, Block Digital created for us, and the plans that I'll be showing you for what we're planning on doing in the future were done by two Nottingham University architect students who the university loaned to us free of charge over summer last year. So we also have a project board that have been helping us out, and they're their names there. Some of you who are from the local area might recognise some of those names, but they've been really good in helping to steer us in the right direction and give us advice. The image on the right, I'll come back to later on, but the sort of pictures that accompany this presentation are all generated to demonstrate what the observatory will look like. So what it looks like at the moment is this area up here, the actual observatory itself. Later on, but the sort of pictures that accompany this presentation are all. Could someone switch their microphones off? I'm getting the double bit of feedback, Rob. I don't know if it's coming from. What the observatory will look like. So what it looks like at the moment is this area. Could someone just mute everyone's mics, please? Because I'm getting my own voice back twice. Thank you. Yeah, so that's the observatory at the top there, as it is now, and the rest of the structures are what we're planning to do in the future. The observatory itself was started back in 1970 by a person called Dave Collins, who I think is actually on this call. This is Dave here, and Dave is still a member, and he put an advert in the local paper because he wanted to form an astronomy society. But the group of people he got together were really ambitious. So instead of just getting small telescopes and putting them out in the field, they wanted to actually build a full observatory, and that's what they set about doing. Now, they didn't have any money. They managed to get some land relatively cheap, but then they set about collecting up all the demolition materials in the area, recovering the bricks and other materials, and so they built the observatory entirely out of recycled materials. This just shows a picture of the observatory as it was not long after it was built, and you can see in the small hexagon in the middle there the first members putting the roof on the dome of the observatory, and inside of that dome is where the main telescope sits. And then that image down the bottom there, you can see they even made their own mirror for the telescope itself. So that's a 24-inch diameter mirror. And at the time, that meant this was the largest telescope in the UK. The public could just come and have a look through on our open evenings. And it still is either joint largest or one of the largest. You can just book a visit to and come and visit in normal times. That's what the telescope looks like today, that bottom left picture. And even the telescope was built out of recycled materials. And the frame of the telescope, those black tubes there, are the scaffolding poles that were used when they were building the building, and they welded those together to make the telescope. The axis that the telescope turns on is the rear hub and axle from a lorry, and there's various other bits and pieces sourced from various places as well. So it was all really built out of recycled materials, and I think it's a testament to those members that that telescope stood the test of time, and most of the telescope is as they built it. Today it's all computer controlled, so we can point and click on the computer screen and the telescope will automatically turn to the object in the sky that we want to look at. And because it's such a big telescope, that's why we have the step ladders there, so you can climb up the telescope and look through the eyepiece, or next to the telescope. A lot of what we do is public outreach. So the last full year before the current pandemic, we saw about 3,000 people through the door. That's a mixture of group visits, so a lot of Cubs and Scouts and Brownie groups, but also adult groups as well. And we were starting to get visits from people, you know, for birthday celebrations. So you might, you know, want to, you know, have an experience instead of a physical birthday present. So we were getting family groups coming along and booking the observatory for the evening. And we'd do a talk very much like the sort of thing Rob's just given. And then you'd have a chance to look through the telescope and have a look around the observatory. Then we do open evenings, which is what this one would have been at the observatory. And we do in the summer, when it doesn't get dark until till later, we do solar days where we have specially adapted telescopes where you can safely look directly at the sun and see things like sunspots and solar flares. We do outreach off-site as well. Last year was the 50th anniversary of the first landings on the moon. And we worked with Mansfield Museum to set up a big exhibition there, funded by the Heritage Lottery Fund. And I think we had about 12,800 people coming through that exhibition. We're using some of those exhibition materials that we're about to in a shop that we've been loaned by the management at the Idlewild Centre in Sutton and Ashfield. And as soon as we're able to, we're going to be setting up an exhibition in there that's just free to come to and walk around as well. So look out for that. We have professional lecturers come along, professional astronomers come along to give lectures. This is a picture of Dame Jocelyn Bell Burnell, who discovered pulsars in the 1960s, which was described as one of the most significant scientific discoveries of the 20th century. And she came along and she gave a talk, and this is just her at a local school that we invited the sixth form, the GCSE students to as well. And we also attend summer festivals and things like that, where we set up a gazebo and set up some solar telescopes and just tell people what we're doing. We've kind of gone further afield than local as well. So this guy on the right down here with the beard is called Bernard, and he's a member who's moved to Hong Kong. And he's now working with, again, just as a hobby, working with a similar sized observatory in Hong Kong. And they're trying to replicate some of the experiences that we've been offering at our observatory. And we're going even further than that. The picture at the top is the James Webb Space Telescope. It's due for launch next October. And that's really the successor to the Hubble Space Telescope. And when you think of the fantastic images that we've got from Hubble and all the science discoveries we've made from Hubble, this telescope is much, much bigger than the Hubble Space Telescope. So we're going to find amazing things about the universe based on the Hubble Space Telescope. And we've been selected as one of only the few societies in the UK to work with the professional James Webb Space Telescope team to help them with their public outreach. So we've been getting some training from the professionals who have built and are going to put the James Webb Telescope into space. And we're going to be rolling out that experience to visitors, and we'll do Zoom meetings and things like that. So watch this space for that. What we want to do is tell as many people as possible about that fantastic telescope and the part that UK scientists have played in building the instruments on the telescope and putting the thing into space. Due for launch next October. So hopefully we can have a special event at the observatory next October around launch day and celebrate the launch. I just wanted now to go on to our plans for the future. So this is an aerial photograph of the observatory. The observatory is here. So there's the dome that I was showing you before. And a few years ago, we bought this land outlined in orange. And you can see on the aerial photograph, there's this kind of circle here where the vegetation is not growing so well. And any archaeologist will tell you, if you see something like that, it means there's something below the ground. So around that circle there with that old building in the middle. If you climb down through the floor of that old building, you end up here. And this is a reservoir that was built in the 1880s to provide water to the area. So it was like the water equivalent of a gas holder. They pump water into the reservoir to store it, and then they pump it back out of the reservoir again to feed the local community through miles and miles of cast iron pipework. And we now own this underground reservoir. As you can see there, there's no water in it anymore. And we've cut a hole in the side so we don't have to climb down the rusty old ladders anymore to get into it. Just give you an idea of scale, there's someone inside of it doing a survey. It's 75 foot across in old money, and that's about 23 meters across. And we've got some great plans to reuse that space going forward. So what we want to do is turn that into a science discovery centre and a planetarium, and I'll show you an animation of what that's going to look like towards the end of the talk. And it's really two things. We want it to be a great place for visitors to the area to go and see. It has the advantage over an observatory that it works in the daylight and it works when it's raining. And really importantly, to protect jobs and grow jobs for the future in the area, we want to use it as a place to encourage people to do science, technology, engineering and maths, and to just get a better understanding of those sorts of things, or you know, even take up careers in it. We did a public consultation a couple of years back and got loads of good feedback that just reinforced our intention to do this. I won't go through all the details there, but you can see a really positive response. We put a box in IKEA, for example, and we asked people to just vote whether they thought it was a good idea or not. That's that third line down. 1,095 said it was a great idea, and 5 people said it wasn't. One of those 5 was the child of someone who came along and said it was a good idea, and there's no way on earth that child was going to give the same answer as his mum. So he voted no, even though she voted yes. And we've had lots and lots of interest from schools as well to send classes during the day and encourage their students to think about astronomy and science and technology and engineering and maths. So we're going to use it for, and these are all animated images, by the way, so none of these pictures are as it is now. They're all what we hope it's going to look like. Even though they look like photographs, they're not really there at the moment. So we're going to carry on doing what we do now, except we'll be able to get more people at the site, more schools to visit, because it's easier to get schools visiting during the day. And we can use it as a community space as well. So for putting on exhibitions, maybe a community cinema. The planetarium in Newcastle, for example, they host weddings there. And I've even been to one where musicians have used it to project light shows that go with their musical compositions. And there's lots of other stuff we can do with it as well. I'll not go through a lot of these, but we've done an assessment that shows that we can make it work in terms of money. So we can get enough income with a very low estimate of how many people we think will get visiting, actually, and we can make it work. And it brings a lot of economy to the area as well, because all those people who visit, you know, go to local coffee shops, maybe they stay overnight, they go and do some other tourist stuff. So overall, it brings some employment to the area as well. And of course, all that money that gets spent on us there, we then re-spend in the local area. So it's kind of important for the local economy. But the biggest benefit isn't the money. The biggest benefit, as I've already mentioned, is how we inspire local people to take an interest in science and technology and maths and things like that. And just really get that understanding of the world. The world's quite a sciencey and quite an engineering place at the moment, so it's important that people understand that. And we'll have a cafe as well, so that you can have a cup of coffee while you're there. So just to emphasize that point, we've got this video, short video of Professor Louise Harrer, who's a very senior physicist. And I won't read it all out there, but she's a very senior physicist, works on various sorts of physics projects. And this short video just explains why she went on to become a scientist. So I'll just play that now. Rob, if you can't hear the sound, let me know.
And we were wondering what led you to the world of astronomy.
I think it was by accident. It definitely wasn't planned. So, I mean, I think many children do, and I was certainly one of them. You were fascinated by space, and my primary school trip to the planetarium was a memorable one, and that's, I think the planetarium is really important in that way, that it gives you the excitement of looking up and seeing what's there. I think when I was in school, I didn't realize you could really get jobs in astrophysics or in space science. So I wasn't, you know, it wasn't a drive for me at school because I didn't know somebody from Lurgan could do that.
So that's just an example of, you know, what impact it can have. And we must also remember that Helen Sharman, the first UK astronaut, it wasn't Tim Peake, it was Helen Sharman, only comes from Sheffield, just up the road. So, you know, if we encourage the next astronaut from the area, that would just be brilliant. So our plan is we're going to do the design next year. It's all subject to getting the money, but we're pretty confident about that. We'll do the design next year. We've got some sources of hopefully money to start building the thing, but we need to find some more. So we'll be doing that in 2022, building it in 2022 and into 2023, and then hopefully you'll be having a grand opening in 2023. Now that sounds a long way off, but it's not. It's only kind of 3 years away. So we've got our work cut out, but you know, you've got to have a plan, and that's our plan, and hopefully that's what will happen. So I've just got a couple of slides left. The first one I'm going to show you is just an animation created by Block Digital for us on what the new facility will look like when it's open. So I'll just run this video, and then I've got, I think, one slide left. See there, we've got the lighting to look like the planets. That's the current observatory in the background, that'll stay. Now, to the best of my knowledge, nobody's ever turned a Victorian reservoir into a planetarium before, so it's kind of not going to be easy, but you know, that's our plan for the future. Of course, there's always a but, and the but in this case is we need as much support as possible, and we need money. So without going all Bob Geldof on you all, we do have external sources of funding, but to fund the next stage, we needed to find £22,500, and our little funding rocket there says we're £12,400 towards that. So we've got just over £10,000 remaining. So there's a full video of this on our YouTube channel about the whole launch event we did the other day. So please tell people about that. And if you like the idea and you like what we've done this evening, then there's an opportunity to give a small donation, or if you're a lottery winner, give a big donation. So you can do that by either going to the site there. Like I say, there's a presentation roughly like this on our YouTube channel, so you can find the same link on that. Or just go to our website. There's a link there. Or you can just contact me direct if you like, and or if you know any companies who would be interested in helping us on this journey, drop me an email. And that is the end of my presentation. So I will stop sharing my screen. And Rob or Brendan, I don't know if there was any.
Hi Steve, it's Brendan here.
Yeah.
Yeah, thanks for that. That's absolutely brilliant. What an exciting future we've got at Sherwood Observatory. So thank you. Right, so welcome to the third instalment of tonight's online event. We'll start by viewing a short 5-minute clip from Sherwood Observatory on site that was filmed on Sunday the 15th of November. So if you just bear with me one moment while I share my screen. So I'm hoping all of you can see this. So this is me at Sherwood Observatory last weekend, filming from the driveway just down from Coxmoor Road. You can see the main entrance there with the signage, welcome to Sherwood Observatory. This is quite possibly familiar to a lot of you, but those who haven't been before, this is who we are and where we are. Okay, so we're just located about a mile south of Mansfield. Ahead, you see a black area on the floor, that's our telescope viewing pad. Okay, to the left, you should be able to see the horizon over Mansfield, and that is pointing north. Okay, so down in the distance there, we've got the new Amazon distribution warehouse. You can see down there, that's a new entity that's popped up recently, scanning across to the car park at the top, parallel to Coxmoor Road. Okay, so we've got our accessibility ramp up to the main entrance to Sherwood Observatory. And what we're just going to do is walk up here, have a quick nose about inside the facility and see what it's like from the inside. So going through the main door there, we've got a accessible toilet on the left. We've got maintenance stores, optic stores located to the right here. To the left, we've got a sign-in book. We've got rogues gallery on the wall. Those pictures you see are committee members. Here we go. This is our bespoke lecture room. Lovely wooden panelling, very indicative of the 1970s and 80s this place was built. Quite often we can entertain up to about 30 members of the public or members of the society in this lecture room. Okay, you can see the chairs are spaced out to allow for a COVID secure facility, but we're not currently open at the moment. On the left side, you can see the notice board with pictures on there. That is picture of the month that members can submit their own picture they take of anything within a 5-mile radius of the observatory site or anything astronomical. It gets submitted into a competition and it's placed on the wall. Okay, so going back through the double doors, sign-in book straight ahead. There's a spiral staircase there going upstairs. To the right here, we can have a quick nose into our office space. So we've got a working office at Sherwood Observatory. This is a quick look and see, desk area. That's all we need. Opposite that, we've got a kitchen that serves as well. Right, so the main bits, here we go, up the spiral staircase into the main dome of the observatory. Just trying very carefully not to trip on the stairs. So the beast you can see in the centre of the observatory is our bespoke 24-inch Newtonian reflecting telescope. Now this telescope was actually built by the founding members. This was not purchased from the shop. Everything is handmade, homemade. All the components are welded together, riveted together and locally sourced. It's quite an amazing piece of engineering actually. The dome with the yellow stripes signifies the aperture opening, which opens electronically. Just walking around the perimeter now to give you a feel for the space we have inside our Sherwood Observatory dome, which is really at the heart of everything we do. Straight ahead, there is a control panel, which is currently going under maintenance upgrade for touchscreen television that will allow the telescope to be operated by touchscreen. At the moment, it can be operated with a handheld device or with the click of a mouse on a planetary software. The telescope will point to any location in the night sky. So you can see light is flooding the interior of the observatory dome. The aperture is opening up. It's a nice sunny day outside. Takes a few seconds for that to open. So towards the top end of this Newtonian reflecting telescope, you can see the eyepiece arrangement poking out at the side. Behind that is a covered diagonal mirror, which actually allows a cone of light from the primary mirror to beam perpendicular to the main axis to view through the eyepiece there. And I'm actually standing on the top of step ladders at the moment to allow accessibility to the viewing eyepiece that you can see in the centre of the screen. Okay. It's just a real shame that we can't be here at Sherwood Observatory tonight to experience this in person, and I really do hope that one day soon we can actually experience the delights of this and actually look through it for ourselves one day at the Moon, at Mars, at Saturn. Actually, they are wonderful sights to look at through this telescope. So as you can see, with the touch of a button, the telescope is actually ramping up in altitude. It is actually pointing towards the zenith at the moment. I think the aperture is coming to a close at the moment as well. Okay, so I think this video is coming to a conclusion at the moment. And that pretty much wraps up the on-site tour I can give you at the moment. Okay, so what this section entails will be the planetarium software, what we can see in the night sky as well shortly after this video. Right, so hopefully you can all see this. This is Stellarium. It is a open source free software planetarium for your computer, for your mobile phone or tablet. You can get it free off the internet, and it's absolutely brilliant. I recommend you do get this. It allows you to view thousands of stars in the night sky. It's got thousands of deep sky objects in its database, and it's powerful enough to actually view the sky planetary positions in the past, present and forward in time. Okay, so I'll take you through how this operates, and hopefully you'll be inclined to download it yourself. So what you can see here on the bottom of the screen, we have some information. Sherwood Observatory at an elevation of 122 meters. The time is currently 20 to 1. Okay, so it's lunchtime, it's today, the sun is in the sky. You can see the cardinal points around the horizon. So just below the sun, you can see S for south, and at a touch of a button.
Sorry, Brendan, you've been muted. Could you unmute, please? Sorry.
Right, yes, I hope you can hear me now. Okay.
Yeah.
So we have Stellarium in operation. If I press the button again, what you see is hopefully the sun setting in the west, and we're hitting upon 3 o'clock, 4 o'clock in the afternoon. Sunset, nightfall comes, and the stars appear. So if I just stop that at the moment, so what we can see is the sun is setting in the west. The brightest objects in the night sky have appeared first, the moon followed by Jupiter and Saturn. So this is what you can expect to see at 5:30 this evening today. I know that's back in time, but that's the beauty of this software. And again, if I click the forward button, time continues to move on. You can see Jupiter and Saturn setting in the west there. Time is racing up to about 7:30 to about 8 o'clock now. So this is pretty much real time. Okay. And if I click on the moon and press the space bar, the moon will center itself on the center of the screen. By clicking on the moon or any object in this software, pulls up information that you can see on the left-hand side. I mean, to be honest, there's too much information there that you need, but it's got some relevant information. It will tell you the distance of the moon from Earth, about 390,000 kilometers. It tells you the magnitude of the moon, which is about -10.8 at the moment. A full moon would be a brightness of magnitude -12. And just to put that into context, the brightest star in the night sky, Sirius, the dog star, would be about -1.6. Venus, -4. The sun in daytime, -27. So there we go. And what we can do is, if we just zoom in on the moon, it will give you a real-time view of the phase of the moon for today, which is first quarter. Okay, so this is actually visible in a constellation of Capricornus at the moment. It rises about 20 to 2 in the afternoon, transits the southern meridian about 6 o'clock this evening, and it will set about 10 o'clock tonight. And all that data you can get from this software. Okay, and what you can see at the moment are obvious features which you can see with your unaided eye. So when you go outside and you look at the moon, you can see these dark patches here called mare or seas. They are quite obvious. With binoculars, you get to see a bit more detail. But this big circular region here is called Mare Crisium, Mare Serenitatis, this one here, and this one below it, Mare Tranquillitatis, the Sea of Tranquility. Okay. So these are quite prominent big features you can actually see on the moon with the naked eye. They are basically large basaltic plains formed by ancient volcanic eruptions about 4 billion years ago, basically. So if we just zoom out of that, back to ground level. So you're standing in the field. Okay, it's 8 o'clock in the evening. These are the stars you can see in front of you. And with the touch of a button, you can actually join up the stars to form constellations in the sky. Okay, and give it some labels. We can see that the moon resides in Capricornus. You can see Mars is up there in the sky as well, in Pisces. Okay, so it's quite a prominent object. You cannot miss Mars at all in the night sky. Even by looking on here, you can see it's got a reddish hue. And if we click on Mars, again, it gives you a lot of relevant information about the planet, of where it is in the night sky, what time it rises, what time it sets, and the magnitude. Okay. So if I press the space bar on this software, what will happen is Mars will go to the center of the screen, and we can just zoom in on Mars. I'm hoping you can see Mars there. Now, the size I've got Mars on the screen is probably akin to what you may see Mars through a telescope live with your eye. Okay. So if we just zoom in a bit more, just to get a bit more detail upon this, and I'm hoping you can see this. You can see 2 star-like objects in front, Phobos and Deimos. These are actually 2 moons associated with Mars. Okay, so they are 2 natural satellites of Mars. They're not as big as our own moon that orbits the Earth. They are more asteroids-like. Phobos is very faint. You're not likely to see it with the unaided eye at all. You need a big telescope to see that, and potentially photographs may show it as well. But Phobos is more asteroid-like. It's probably about 12 kilometers in diameter. Similarly, Deimos is of a similar distance as well. Okay, so if I click on Mars again, Mars does exhibit some features that you can actually see through a telescope, and as you've probably all gathered, we cannot see much of the sky tonight due to the weather over the Midlands is cloudy. But I've got some pre-recorded video of Mars through a telescope I can show you after this. So looking at Mars on here, you can see there is a bit of a prominent polar ice cap at the bottom there. You can see some features at the top of Mars as well. If you can see my cursor, that is one of the largest volcanoes in the solar system, which I think Rob talked about in his first talk. That's called Olympus Mons. And that is something like 21 kilometers high. Okay. Okay. Further around the planet, you can see some scars here, which is a Grand Canyon type feature called Valles Marineris. And that's about 2,500 miles in length by about 250 miles in width. I mean, that Grand Canyon is what, 250 miles by 18. So this is a significant structure on the surface of Mars. And just be mindful, Mars is only about a quarter of the size of the Earth as well. Okay. And these dark features here are really pertinent to 1/2 of the hemisphere of Mars. And you can see quite a distinction between the 2 hemispheres of Mars. One is a lot smoother and lighter, and it's got a lower sort of regional ground to it than the darker uplands of the southern hemisphere here. That's known as a Martian dichotomy. Okay. So if we just pull away from Mars, we zoom back out. So we're back to standing in the field of a starry sky. And the key is to actually learn where these stars are in the sky. But the beauty of this software, you can actually join up the stars and make out the constellations. Okay. So we can see Mars is in Pisces. We've got prominent constellations that will become more visible later in the evening, such as Taurus. Orion is rising in the east, an absolutely beautiful constellation. And what we can do is just forward time a bit more, and you can see the stars rising in the east. And those who know a little about astronomy probably will recognise a lot of these constellations at the moment. So at the front, we've got Orion. We've got the belt, 3 in a line, and that's a good indicator to point where Sirius, the dog star, is, which is the brightest star in the night sky. Okay, so that's one way to find your bearings around the night sky, is to actually take the 3 in a line belt of the stars of Orion. And if you go upwards, it actually points to Aldebaran, which is in a nice little V star cluster region of Taurus. And a bit further up, we have a nice little open cluster called the Seven Sisters, or the Pleiades. And it's always a little fuzzy object that does capture your eye in the evening during winter and autumn time. Okay. So if we just pop on the constellation lines again, you can see that. What's kind of useful as a bit of a gimmick, if I just press this button here, you can see an overlay of like the mythical sorts of figures the constellations represent. So you can see Orion is depicted as the hunter. You can see Taurus as the bull, with Aldebaran, a bright star there as the bull's eye. Okay. And Gemini, the twins there. So if I just remove that and take away the constellation lines, if we just take a gentle peruse from the south, southeast, and look towards the north. Okay, so we're looking at the northern sky at the moment. And if I put back the constellation lines, you might be able to recognize a few here. So this star, this one, this one, this one, and that forms a frying pan. So if you can see my cursor go around it, that is known as the Great Bear, or Ursa Major, as it's called. And if I put on the Great Bear representation, you can kind of get a picture of why it is called that, really. And similarly, there's a little bear here known as Ursa Minor. So the little bear is Ursa Minor, and the major bear is Ursa Major. And what's significant about one of the stars in the northern region of the night sky is this one here in the centre. That's called Polaris. It's called Polaris because it actually resides at the north celestial pole of the night sky, which is very useful to us in the northern hemisphere, because the height of that above the horizon is actually the same as your latitude here in Mansfield. So we're 53 degrees north, and that star there, Polaris, is about 53 degrees north above the horizon there. So if you was to walk towards the North Pole, you'd gradually see Polaris get higher and higher in the sky till it actually reaches overhead to the zenith, as it's called. Okay. And just to put that into perspective, what I can do is, even though the time on this planetarium software says it's 1 o'clock in the morning, if I actually forward the time, you can see the stars begin to turn and they rotate. Okay, so they rise in the east and they set in the west. And that's a consequence of the Earth turning. Okay. So there's another star I'd like to point out in the night sky in the constellation of Ursa Major is this one here. It's called Mizar. Okay, so if I just move that to the center of the screen, it's actually known as an optical double star. And for a long time now, for hundreds of years, it's been kind of an eye test for sailors out at the sea. You know, there was no Specsavers back in the day, so if you needed to check the vision of your eyesight, then you'd be advised to look at this double star here, which is Mizar. And if I zoom in on this, you can actually see it's got an optical companion called Alcor. And this separation here is actually just about achievable with the naked eye if you've got 20/20 vision. Okay, so all I can say is to be mindful of the distance between these two stars here at the moment. it's actually about 11.8 arc minutes in distance between the two. And that's just a measurement astronomers use to measure distances on the night sky. To put it into context, the moon's diameter on the night sky is about half a degree. So astronomers use distances as degrees, minutes and seconds. And the distance between these two stars is 11.8 minutes. And if you just hold that thought for a minute, and what I'll do is just highlight an event that's going to happen next month, which is worth mentioning because it's something we all can go outside and have a look at. Okay. So this planetarium software, if I go to the left-hand side here, click on date and time, if I slowly move the date forward, so 28th, 29th, 30th, 1st of December, and keep going, you can see the sky change, the moon is moving each day. If we take it to about the 16th, and if we ramp up the time, let me just come out of that a minute, and move over to the western horizon, because this is where we want to be looking, to be honest with you. If we go back to the date and time here, we can see it's 4 o'clock in the afternoon, 6 o'clock. So what we've got in the sky on the 16th of December is a nice moon setting in the west after sunset. We've got Jupiter here, but also very close by, we've got the planet Saturn. And that's kind of significant for this year, simply because these two planets that are setting in the west after sunset, that on the 21st of December is going to be the closest they've been together since about 1623. Correct me if I'm wrong, but I think that is the date they were the last close together. And this is really close. And the distance between those double stars I just showed you in Ursa Major, Alcor and Mizar, being a distance of about 11.8 arc minutes, well, these two separation will be 6 arc minutes on the 21st of December. And so what I'll do is just change this date from the 18th, 19th, 20th, 21st to about 20 past 4 in the afternoon. If you look towards the west after sunset, you'll probably see a singular star-like object, and that will be Jupiter and Saturn pretty much overlaid each other. With binoculars or telescope, you begin to resolve them. So what we'll do is we'll just zoom in. So what we can see is, through a telescope, this is what you would see: Jupiter with its 4 Galilean moons, and you see Saturn with a family of satellites as well. Okay, so this is actually doable through most telescopes. If you get your eyepiece, that gives you a magnification of your telescope just right, it's hopeful that you'll see both planets at the same time in a single telescope. And this is called a conjunction. Okay, so look out for this on the 21st of December this year in the afternoon after sunset. Okay, so if I just come away from that. So that concludes the Stellarium part of this talk. So if I come out of that, and I'll show you some live video footage I did of Mars last week, because it's currently cloudy at the moment. This is the best I can do, I'm afraid. So if I share a new screen, just bear with me. Right, almost there. Right, so I'm hopeful you can all see that. Okay. So what we have in front is a pre-recorded view of the planet Mars through a telescope taken last week when the seeing conditions was actually quite good. Unfortunately, as I said, tonight is cloudy, but this is the best we can do. So if I was doing a live feed tonight, this is essentially the sort of view you would be seeing of Mars at the moment. So what we've got coupled to the telescope is a monochromatic dedicated camera, because mono cameras are actually more sensitive than colour cameras. And this piece of software is called Fire Capture. It's a free piece of software that you can get off the internet that controls a camera for the telescope. And you probably can see me just tweaking a few controls on the left side there, changing the exposure, changing the gain as this runs through. Okay, so if I just put that on repeat, because it is a loop of some video footage of Mars, and the seeing conditions of what you can see on Mars is largely dependent on your local weather conditions, really. I mean, it was not that great, but what you can actually see here is a perceived planetary disk that's got a reasonable sort of diameter through the telescope. So the camera is connected to an optical amplifier, a ×5 power mate, which gives it a boost as such. And this is working at what's called f37. Those who know a bit about telescopes probably understand that. Okay, so this feed of Mars, you can actually see it's got a bit of a surface feature going on there across it. It's got a darker side to the hemisphere as it has to the other. The smooth, brighter side is known as a Martian dichotomy. Okay, so the bottom of the Mars, you can see, is dark due to the rough sort of terrain that is highlands of the southern hemisphere of Mars compared to the smooth, lighter northern regions. What you can't actually see on here at the moment is any more features. You get a few tantalising glimpses of the southern polar ice cap on there, but I'm afraid it's just not clear enough to actually see that at the moment. But I do have another quick snapshot of a processed video of what I use this for, so I can share that in a second. So if I just stop that and hopefully pull up a new screen. Right, okay, so what he was looking at a minute ago with the live feed of Mars that was taken last week is in this box on the top left. A quick processed version of that is what you can see here on the right side. And you can see it's very much similar, but it's a little bit more detailed, not a great more detail, but you can see a few more prominent features on there, which just emphasises the Martian dichotomy between the northern hemisphere and the southern. And you can just about make out a small white tip at the bottom there as the polar ice cap. I mean, that is diminishing anyway due to the fact it's getting closer to the sun, and the carbon dioxide in that ice cap is actually melting. So that is currently disappearing. Okay. So I'm afraid that's all we can deliver in terms of giving you a view of Mars. I know it's a bit artificial and disappointing. It may seem somewhat underwhelming, but there's no substitute for the real thing. But that's just a consequence of living in the UK, I'm afraid. Okay. So I hope that's come through okay to you lot.
Yeah, that worked really well, Brendan.
Okay, so I think that pretty much concludes my part of this evening's talk. So I'm happy to take questions once I've come out of this screen sharing.
Yeah, well done, Brendan. That was great.
Okay. Right. So I don't know if we've had questions pop up in the chat at all.
I'm watching YouTube, Brendan, by the way.
Right, okay, so that's probably still playing out on that.
I think we're on top of questions on the chat, Brendan. So just a reminder to anyone, if anyone does have a question, just type into the chat and we can relay it to Brendan to answer it, or myself, or Rob for that matter.
Yeah. Okay, that's great. Well, I certainly hope you've all enjoyed tonight's live stream from Sherwood Observatory, the 3-part series we've done. It's the first one for us to go live in this means. It's been educational for us lot, and I'm sure for you as well.
Just an indication there, Brendan, and for everybody else, there's been over 380 people on this evening. Didn't want to tell you that before you started talking, Brendan, in case it made you nervous.
No, I was mindful of the YouTube stream I've got set up on my alternative laptop here. It is flagging up about 300 at the moment.
Brilliant.
I think all in all, it went pretty well, actually. To say it's the first time we've done this.
So, do you want to say any words to wrap up, Rob? Or?
Well, only that I'm really pleased that everyone's joined us tonight, and hope you've really enjoyed it. And like I say, if you have any questions even later on, you can contact us at Sherwood Observatory. You'll have all our contact details on our website, and we'll be more than happy to talk to you on anything astronomy. So I really appreciate you all joining us tonight. And like I said, I hope you've really enjoyed it and found out a lot of useful information about exactly what Mansfield and Sutton Astronomical Society are all about.
Right, very good. Right, I mean, we potentially could unmute everybody if anybody wants to flag up their hand and ask a question direct. You're more than welcome to.
Yeah, okay,
I
yeah.
see a problem with that if we want to play it that way.
Okay, yeah, fine.
I'm not averse
Have you
to
got the,
people verbally speaking.
because my chat just hasn't been working correctly.
It's
just,
I believe, I don't know if Chris can actually unmute them all. I'm just looking for the function here and participants.
Yeah.
Not at the moment.
No. Mute or no.
Okay. Well, if anyone wants to type a question in the chat, we'll keep an eye on it.
Well, of course, yeah.
Is that unmuted, everybody? No.
Brendan, or Rob, we've had one question in saying, how old is the planet Mars?
Well, gosh. Well, it's believed that the planet Mars is around 4.5 billion years old, looking at the type of rocks what have landed here on Earth. So, which is roughly the age of planet Earth as well. I don't know.
Okay.
What?
Yeah.
How do you go about joining the Sherwood Observatory?
Yeah, joining the society, you can do that by accessing our Sherwood Observatory webpage. There is a section for membership on there, and you can actually download an application form and just post it back to us. Should you have any problems with doing that, please do contact us.
Okay, righto, Tom. That's a lot, Tom.
I've got a question from Alison, Deborah and Sam. Yes, we absolutely do allow non-members to visit the observatory. And ordinarily, when we're not in lockdown with this pandemic, we do allow visits to the observatory. We do have dedicated open events, that sort of thing, which we do allow members of the public to come down and actually view all the observatory inside and enjoy the telescopes. But for a private visit, it is best to contact us to arrange something privately.
I'd like to ask a question, please.
Fine.
Yeah, sure thing.
Hi, Graham.
I sent a couple of messages with my question, so ignore those. And I'll say what it is. I was just wondering whether there's anything currently actually orbiting the moon, that any man-made stuff orbiting the moon, like keeping a close eye on on anything that's going on.
I think there are a few reconnaissance missions actually in orbit about the moon. There's a lunar reconnaissance orbiter. I think JAXA Space Administration have got one as well going around there. I can't think of any more off the top of my head at the moment, but
hang on, I can probably throw one or two in there. There's probably was there the last Chinese one?
Yes,
Chang'e.
Chang 3, is it? 3
I can't remember now.
Something like that, isn't it? They have landed, yes. They got a lander down there, and I believe an orbiter on it there as well.
There's a couple of questions I can probably answer here, if you want me to go for it.
Okay.
How far away is Saturn? Came up, and about 1.5 billion kilometers is the answer to that one.
Was one of what is the oldest planet. It's believed Jupiter was the first planet to have formed because it's simply the biggest of all the planets in the solar system. So it's believed Jupiter first, then followed by Saturn.
What's the best way to understand albedo? And that's just the percentage of the light which is reflected back. Yeah.
Yeah, absolutely.
So a mirror will have an albedo of 1, and a completely black absorbance surface will be 0. And let's say the Earth is 0.39. It's one of the only facts to remember about albedo.
I think certainly some of the brightest planets is Venus, with its thick cloud deck. It's got quite a high albedo, I think, similar with Jupiter, I think.
It is, and if people have never seen the planet Saturn through a telescope, because that is the only way you'll see the rings itself, you'll literally go wow when you do view it through a telescope, because it is a beautiful planet. Thanks, Angus, for your kind words.
Yeah, there is. You can get great pictures of Saturn from NASA and places like that, but no matter how good the picture is, it's not as good as looking through a telescope and seeing it for the first time with your own eyes.
Yeah, when it's live, so to speak, it is a real personal experience. Never get tired of viewing Saturn. But there's lots of planets, like I say, all up until to Saturn, what you can see with the naked eye. No optical aid is required. You can actually do a lot of astronomy just with the unaided eye. It is, so you don't have to spend a great deal to do astronomy. It's there, all you do have to look up. It's fantastic. It's up to you if you want to buy any optical aids to, you know, take your enjoyment further, so to speak.
We have a question from YouTube. What is the biggest star?
Oh.
Changes every time I look at it.
Yeah, it does. I think it's in excess of about 300 solar masses, I think.
I forget which one it is now.
Is it UY Scooty? I think there's R136A, which I think is in the Tarantula Nebula. There's a cluster of stars visible from the southern hemisphere, I think, in the Large Magellanic Clouds. I think there's a few stars there, but they are humongous, about 300 times bigger than our own sun.
Hi, Kian Eves, and to everyone. Yes, we are hoping to do more events like this, even when we do get out of lockdown and we can all get back together without all the social distancing. We will be doing this because it just allows us to reach a bigger audience and people who, for whatever reason, can't get to the observatory, because we are limited to the amount of people we can have on site. So yes, we will be doing more of these.
Did I understand?
I think the other thing to point out is if you go to our YouTube channel, I know some of you are already on it, we've got quite a lot of recorded presentations that we've done in the past as well.
Did I understand somebody to say that there is an area at the observatory where members can set up their own telescopes?
Yes, that is absolutely correct. We've got what we call a scope pad. Just as you come down the driveway and go through the Ochra, where you go right into the actual observatory. If you carry straight on, we've got a rubber covered surface where we put telescopes up. We've got a permanent mount there, which is polar. You know, we just drop the mount on and it's pretty much lined up with the North Pole star. So yeah, that is an area where members can go down, put their own telescopes up.
Thank you. Thank you for the very entertaining evening.
Thank you, Graham. Really appreciate you joining us.
And good night.
Good night. Enjoy the rest of the weekend.
Take care.
You too. You too. Bye-bye.
I think a question popped up, are there going to be any more Zoom calls like this? And I think it's safe to say we're likely going to roll out a few more like this, and hopefully we'll get better at it as well.
Yes. So we really appreciate, this was our first major one. We really appreciate your patience in hanging in there with us. So we will hopefully get better. But yes, we will be doing this more because it's a great way of reaching people. We'd like to involve and get, you know, out talking to as many people as possible and just hopefully guiding them so they can enjoy the night sky.
And as soon as we can reopen again so you can come in person, we will.
Absolutely. If you keep watching our website, because as soon as we can, we certainly will open back up, as long as we can be safe with everybody. But it just makes you wonder when you look at planet Mars, for example, and all the evidence, how it points to how it was a long time ago and how it is now. I think we can learn a lot from Mars on how to look after our own planet, because we live on a beautiful planet and we really need to keep it this way. So it costs a lot of money, time and effort to send probes and landers to Mars, but we can learn an awful lot. And I think that will be vital in the future of Earth, actually. So it isn't a waste of time. It's a great educational project, because when NASA goes there, pretty much all the information these rovers gather may cost billions of dollars to build, launch, and actually run, because the Curiosity and Perseverance is slated for about 15 years of life if they don't break on the surface of continuous running. So that costs a lot of money to do that, and all the information is freely available for us to learn by. So that's a great thing to do. Certainly isn't a waste of money. As humans anyway, we need to explore, we need to find out, we need to lift that rock and see. What's a good telescope for a child? Okay, Brendan or Chris. One what's used regularly is the best telescope.
We were asked this question the other day by somebody who's been supporting us, one of the organisations who's been supporting us, who wanted one for the daughter for Christmas, and one of the best places to start. If you were here in person, then we could stand by you and have a long conversation about it, or at least Chris could, because he's best at this. The short answer is look on something like Rother Valley Optics website, and they have a page for starter telescopes and for children telescopes and for really expensive telescopes as well, depending on what your budget is. So do something like that.
Yeah. A pair of binoculars is also very good. They're very good grab and go, probably a 10 by 50, because they're easily light enough to use as well. And they give great views of the sky. Very, very easy to use.
Well, the other thing when we're open again is just join and come use ours.
Oh, absolutely. We have got a big toy cupboard. So we just like people to use them. Okay, yeah.
Right, so we're at 8:30 now. We've got 33 participants still left on Zoom. So
what two or three websites were mentioned earlier?
Okay.
Oh, okay. Oh, yes.
Well, what? Sorry, Chris.
Somebody's asking what's the 2 or 3 websites are. I'm not sure what it's relating to. Whether it was some mention in the meeting.
Well, it's definitely ours.
I mentioned our YouTube channel where we have recordings of various lectures. I mentioned our website. So if you Google Sherwood Observatory, you find our website, and that'll have links on it to, if the question was about you want to give us some money, then there's a link on that to give us some money. Or I guess if that doesn't answer your question, drop us an email and we can answer the email. Or the other one is the Stellarium software, I guess. So if you look for Stellarium, you can download what Brendan was using.
Yeah. Yeah. Any more questions? Feel free to put your hand up and ask one.
Brendan.
Barry, how you doing?
Barry.
Yeah,
Barry,
fine,
Barry.
thanks you. Good evening.
Very good.
I've got the largest star down in the Milky Way as the Pistol Star.
Right, yes.
Which is in the constellation of Sagittarius, which is near the galactic centre, and it's 100 times the mass of our sun.
I think you could be right there. You're going to have to be careful of what you distinguish as the largest star or the most massive star. I think what I was saying before was probably the most massive star, but I think you're right in saying that's the largest star.
I think it's the other way around, Brendan. That's the largest star by mass, but not the largest star by a diameter, because you get stars that are sort of quite puffed out as they get to the end of their lives, in particular red giants, which might not be any more massive than the sun, but might, you know, the outer edge could be all the way out to somewhere like Jupiter if it was in our solar system.
Yeah, a little bit like Betelgeuse.
Yeah. but it's
The
not the
size
massive
isn't
flyweight.
everything anyway.
Well, stars, heavier stars than the sun don't burn for as long, so there's a lot less of them around because they burn more brightly, they burn their fuel more quickly, so they don't last as long as a smaller star.
I think Pete Gill was popping his hand up. Is that right? You're gonna have to take this off mute. No, okay, no worries.
I think he's just said bye. Actually, that was all.
Okay,
He's just
cheers,
waving
Pete.
goodbye.
Yeah, cheers for that,
Talking,
Harry.
you're on mute.
Yeah, I seem to have exhausted the questions.
Okay.
I just wanted to say thank you, everybody, for this. It's been a fun evening. Thank you.
Oh, cheers, Emma. Thank you very much. I'm glad you enjoyed it.
All right,
Like I
thank
say,
you.
we'll try and get the information out quicker for another event like this as soon as possible.
Brilliant. Yeah, really good.
Thank you. Enjoy
Really
the
enjoyed it.
weekend.
You too. Thank you.
Bye-bye.
Bye.
Take care.
There you go. Question about planetarium cost, likely cost.
Right, I've just answered it on the chat as well.
There you go.
We think it's about 4.25 million, something like that. But our first priority, and we think the Heritage Lottery are interested in funding at least some of it. Our first priority, as I mentioned in the talk, is we need to raise £22,500 as a matched fund to release a much bigger pot of money to do all the design and planning applications and stuff like that. So that's what we're focusing on at the moment. We've got lots of companies helping us, but sometimes you need the hard cash and not the help. But the amount of help we got off local companies has been absolutely fantastic. So lots of people are interested in seeing this come to life. So watch this space.
Yes, absolutely.
And if any of you win the lottery, think of us.
Yes, we'll name the planetarium after you, promise.
Peter Buckland's waving. If you want to ask a question, just unmute and you can ask it.
Should we reach in for the unmute, possibly? No pressure.
Got to invite to unmute. Or...
Seeing anybody?
No, everybody can unmute themselves.
Oh, okay.
Yeah.
Fair enough. There's only a few diehards left, so
yes, there's nothing else better to do.
There's still 100 on YouTube. Wave to them.
Okay, yeah. Hello YouTube. Thank you for joining us.
Okay.
That's good to hear, Sarah. Yeah, sort of come along when you're able and bring your daughter and have a look around.
Yeah, we'll do our best to inspire her.
And it's great as well if you're starting a career in something like that to help with outreach. It looks good on your job application forms if you're helping out with something like an observatory. How's that for a plug?
There is actually lots of jobs available in the space industry. We can't all be space men and women, but there's huge amounts of jobs available. Like the James Webb Space Telescope, one of the critical instruments, the infrared camera, I believe, is built in this country. And that will be flying on the James Webb Space Telescope. Cutting edge technology from this country.
You do have to be patient if you're doing something like that, Go. The person who was working on that instrument spent 20 years building it.
So it better fly. Yeah. So this,
okay,
this
should we call it a night there then? I think we're.
I think so. Yes, I think we're pretty much. Yeah, we're down to 14. Yes.
So.
Brilliant.
Okay.
Thanks everybody for joining in. We really do appreciate this. And look out for more information for future webcasts, YouTube and Zoom meetings from us. So thank you and good night from me. Really appreciate it. Thank you.